Good evening. Yesterday we discussed the concept of sigma notation. Then we discussed three important sums. Sum of the first n natural numbers, that is sigma r, which is n into n plus 1 by 2. Sum of the squares of first n natural numbers, that is sigma r square, which is n into n plus 1 into 2n plus 1 upon 6. Then sum of the cubes of first n natural numbers, that is sigma r cube, which is n square into n plus 1 square by 4. Also, sigma 1 is nothing but n. Now we start solving sums from exercise 2.6. Let me explain this. Just listen to me. Please do write this after the lecture. Find the sum sigma r plus 1 into 2r minus 1, r goes from 1 to n. I hope you will not say sigma of product is product of sigmas. You have to open the bracket. Simplify this to get what? If you open the brackets and simplify, you get 2r square plus r minus 1. Okay. Now use properties of sigma notation. So this is nothing but 2 sigma r square plus sigma r minus sigma 1. What is sigma r square? It is n into n plus 1 into 2n plus 1 upon 6. You have to directly substitute the values. What is sigma r? It is n into n plus 1 by 2. Right? And what is sigma 1? It is nothing but n. Now, after this, what remains is simplification. Most of the students find this difficult, but this has nothing to do with 11th standard mathematics. Okay. So you should be able to do this. Here n is taken common, LCM is obtained and simplified to get n upon 6 into 4n square plus 9n minus 1. Okay. Now how will you verify this? Put n equal to 1. So 9 plus 4, 13. 13 minus 1 is 12. 12 upon 6 is 2. Let us check. Put r equal to 1. See, this is TR. So put r equal to 1. You should get T1. 1 plus 1, 2. 2 into 1, 2. Yes. Right? So this is how you can verify the answer. Second, find sigma 3r square minus 2r plus 1. R goes from 1 to n. Properties of sigma notation. So this is 3 sigma r square minus 2 sigma r plus sigma 1. What is sigma r square? N into n plus 1 into 2n plus 1 upon 6. What is sigma r? N into n plus 1 by 2. What is sigma 1? N. Now I have not written that step, but 3 2s are 6. So LCM is 2. In the same step, I have taken n common to get in bracket n plus 1 into 2n plus 1 minus 2 in bracket n plus 1 plus 2, because when LCM is 2, this becomes 2n, but n is taken common. So plus 2 only. Now open all the brackets to get final answer as what? N by 2, 2n square plus n plus 1. How will you verify this? Put n equal to 1. So that gives me 2 plus 1 plus 1. So 4. 4 upon 2, that is 2. Just a minute. Now put, this is actually TR, rth term. So put r equal to 1. So T1, 3 minus 2 plus 1, 2. Yes. Okay. Right now. Third one is good one. Sigma 1 plus 2 plus 3 up to r upon r. R goes from 1 to n. See, what is numerator? Sum of the first r natural numbers. We know that sum of the first n natural numbers, n into n plus 1 by 2. So what will be the sum of the first r natural numbers? R into r plus 1 by 2 upon r as it is. R gets cancelled. So effectively it is just r plus 1 by 2. Now 1 by 2 outside sigma. Sigma of sum is sum of sigmas. What is sigma r? N into n plus 1 by 2. What is sigma 1? N. Here the sequence part is over. What is important is now simplification. LCM is 2, then take n common and so on to get final answer as n into n plus 3 by 4. Next one is similar, but still we'll solve this here only. Start solving sum number 4. Fourth one, I hope you got the meaning of this. See, basically, this is rth term. So what will be the first term? See, this is TR. So in rth term, numerator is sum of the cubes of first r natural numbers and denominator is r into r plus 1. So can you tell me what is T1? T1 will be 1 cube upon 1 into 1 plus 1. What will be T2? T2 will be 1 cube plus 2 cube upon 2 into 2 plus 1. What will be the third term? T3. It is 1 cube plus 2 cube plus 3 cube upon 3 into 3 plus 1 and so on. Right. Now tell me, can we simplify numerator? See, numerator is sum of the cubes of first r natural number. In the last lecture, we obtained sum of the cubes of first n natural numbers. Now variable is immaterial. Instead of n, here number of natural numbers is r. What is sum of the cubes of first n natural numbers? It is n square into n plus 1 square by 4. So what will be the sum of the cubes of first r natural numbers? Obviously, it is r square into r plus 1 square upon 4. Now you may ask me, why not to use that in case of denominator? See, denominator is simply given as r into r plus 1. So there is no point in, I hope you understand the difference between this. Okay. Now simplify. And that is why I have mentioned the reason here. You may ask me, can we write, instead of I cube, can we write r cube? R goes from 1 to r. Yes. You can do that also. Okay. Now simplify this. R into r plus 1 gets cancelled. So what remains is this only. Right? And therefore, 1 upon 4 is constant, r square plus r. Now use properties of sigma notation. So this is 1 upon 4. Use brackets. Sigma r square plus sigma r. I hope you won't say taking sigma r common. That is absurd. Because sigma r square is not sigma into r square. So you're not supposed to do that. Substitute the values and simplify. Tell me the final answer. So what is sigma r square? It is n into n plus 1 into 2n plus 1 upon 6. What is sigma r? N into n plus 1 by 2. LCM is 6. Okay. So it is 1 by 24. What can be taken common? N into n plus 1. So we get 2n plus 1 plus 3. That is 2n plus 4. I haven't written that step. From 2n plus 4, take 2 common to get n plus 2. Now 2 upon 24 is 1 by 12. So final answer is n into n plus 1 into 2, n into n plus 1 into n plus 2 upon 12. How will you verify the answer? Put n equal to 1. So this is 1 into 2 into 3. So 6 upon 12, that is half. Just a minute. Now put r equal to 1. R equal to 1 means up to 1 cube you have to consider. So 1 cube is 1. Because see, what is numerator? Sum of the cubes of first r natural numbers. Now r is 1. So will you say sum of the cubes of first one natural number? No, that is cube of first natural number only. 1 cube, that is 1. 1 upon 1 into 2, that is half. Yes. Right. Fifth one, find the sum 5 into 7 plus 9 into 11 plus 13 into 15 up to n terms. See here you will notice that each term is product of two numbers. And one more thing, we are not given the general term, maybe nth or rth. See, you should know that we are asked to find T1 plus T2 plus T3 up to Tn, which is nothing but Sn. Now Sn is sigma Tr. R goes from 1 to n. You can check this. Put R equal to 1. So T1 sigma stands for summation. So plus next value of R is 2. So T2 up to upper limit Tn. And that is why I always insist that you must find Tr. You may also say we will not write Tr. We will write Tn. Then n goes from 1 to n. Yes, that is also correct. Okay. Now listen to me. Each term of this series is product of two numbers. Observe the first numbers. The first numbers in the product are 5, 9, 13. What is their speciality? They form an arithmetic progression whose first term is 5 and common difference is 4. Hence, the first number in the rth product is what? A plus r minus 1 into d. That is 4r plus 1. You can check this. What is first number in the third product? R is 3. 12 plus 1, 13. See the cursor. First number in the third product. This is not at all difficult. And that is why, though in the syllabus, they say it includes geometric progression and harmonic progression. Still, you should know about arithmetic progression also. Because in series, you need that. Now, what about second numbers? The second numbers in each product exceeds the first number by 2. Or you may also say that what are the second numbers? 7, 11, 15. These are also in arithmetic progression. First term is 7. Common difference is 4. Use this formula. Or here they have used the logic. The second number in each product exceeds the first number by 2. Hence the second number in the rth product will be 4r plus 3. And therefore, TR. Why are we interested in TR? Because this sum is nothing but sigma TR. Okay. Now, anyway, we have to open the brackets. So they are opened here only. So what is TR? 4r plus 1 into 4r plus 3. That is 16r square plus 16r plus 3. See, before we proceed, let us verify this. Put r equal to 1. 16 plus 16, 32 plus 3, 35. See whether the first term is 35 or not. Yes, 5 into 7 is 35. Means what we have obtained is correct. Okay. Now, what is Sn? Sigma Tr. R goes from 1 to n. Properties of sigma notation. So this is 16 sigma r square. We know sigma r square. Plus 16 sigma r. What is sigma r? It is nothing but n into n plus 1 by 2. And what is sigma 1? N. Substitute the values. Most of the students find this part difficult, finding LCM and so on. If you simplify, rearrange the terms, you get final answer. You get final answer as what? N upon 3 into 16n square plus 48n plus 41. N upon 3 into. How to verify? Put n equal to 1 and see whether you get 35 or not. Sum number 6, find the sum 2 square plus 4 square plus 6 square up to n terms. Now note that if you simplify this, then 4 plus 16 plus 36 plus 64, the terms are neither in AP nor in GP. But if you observe the bases, what are the bases? 2, 4, 6, 8. These are in arithmetic progression with first term 2, common difference also 2. So base in rth term is what? A plus r minus 1 into d. That is 2r. You can verify this. See, before you verify, you should not write the next step. What is the base in third term? Is it 6? Yes. But note that rth term is not 2r. This is the base. Index is same throughout. 2. So rth term is nothing but 4r square. So what is Sn? It is nothing but sigma Tr. R goes from 1 to n. Simplify. So sigma 4r square, r goes from 1 to n. So this is 4. What is sigma r square? Okay, I'll write that step. Sigma r square, r goes from 1 to n. So this is n into n plus 1 into 2n plus 1 divided by 6. Now, this is not the final answer because both numerator and denominator are divisible by 2. See, this is the final answer. You can verify. Put n equal to 1. So 2 into 2, 4. 4 into, basically n is 1. So 2 into 2, 4 into 3 upon 3. So 4. Is first term 4? Yes, 2 square, that is 4. Or you may say 2 is 2 into 1. I'm considering bases. 4 is 2 into 2. 6 is 2 into 3. 8 is 2 into 4. Right? So from each term, 2 square can be taken common. So in bracket, what remains is 1 square plus 2 square plus 3 square up to n square. 2 square is 4. Now this is sum of the squares of first n natural numbers. Naturally, we will write n into n plus 1 into 2n plus 1 upon 6 for that. For this method also, you'll get full marks. Sum number 7. Find 70 square minus 69 square plus 68 square minus 67 square plus 66 square minus 65 square up to 2 square minus e square. Now each bracket is of which type? A square minus b square. What are the factors? A minus b, a plus b. Now you will notice that these are consecutive, not consecutive rather. Any natural number less 1. So the difference is going to be 1 only. See, 70 minus 69, 1. 68 minus 67, 1. I haven't written the next one, but it is 66 minus 65, which is 1. Okay. So it is 70 plus 69 plus 68 plus 67 up to what? 1. I have written smallest number first. So basically the sum is 1 plus 2 plus 3 up to 70. This is sum of the first 70 natural numbers. And therefore, it is sigma r. R goes from 1 to 70. What is sigma r? N into n plus 1 upon 2. Now n equal to 70. Substitute and simplify to get final answer as 2485. Sum number 8. Find the sum 1 into 3 into 5 plus 3 into 5 into 7 plus 5 into 7 into 9 up to what? 2n minus 1, 2n plus 1, 2n plus 3. Luckily here nth term is given. Otherwise, first we'll have to find that. Or in general, we find TR, that each term is product of 3 numbers. First numbers are 1, 3, 5, which are in AP. First term 1, common difference 2, and so on. Second term is obtained by adding 2 to first, and third term is obtained by adding 2 to second or 4 to first, and so on. But here we can directly write TR. You may say, can we write Tn equal to this? Same thing. Now Sn is sigma TR. R goes from 1 to n. Note that sigma of product is not product of sigmas. So first you have to simplify this. 2r minus 1, 2r plus 1, 4r square minus 1 into 2r plus 3. You get this. Now use properties of sigma notation. So 8 sigma r cube. Do we know a sigma r cube? Yes, we do. Plus 12 sigma r square we know. Minus 2 sigma r we know. And sigma 1 is n. Now simplify by finding LCM. Only n can be taken common. Tell me the answer. Okay, now simplify. 4 2s are 8, 6 2s are 12, 2 cancel. Now take, so what remains is this. Now take n common from these terms. open all the brackets, simplify to get this as final answer. Now you should check this answer. How? Put n equal to 1. So 8 plus 2, 10 plus 7, 17 minus 2, 15. Is first term 15? Yes, 1 into 3 into 5, 15. Sum number 9. If 1 into 2 plus 2 into 3 plus 3 into 4 plus 4 into 5 up to n terms upon 1 plus 2 plus 3 up to n terms is 100 upon 3. Find n. Now numerator, each term is product of two numbers. Okay. So observe first numbers 1, 2, 3, 4, etc. So in rth term, first will be r only. If possible, write this explanation part also in exam. Now second is obtained by adding 1 to the first. See. So r plus 1. Denominator, sum of the first n natural numbers. So it is sigma r. Now r into r plus 1 is what? R square plus r. Properties of sigma notation. Sigma r square plus sigma r upon sigma r equal to 100 upon 3. Now I will split numerator. You may say we will not do that. We will substitute the values and simplify. Okay, we can do that also. What is sigma r square? It is n into n plus 1 into 2n plus 1 upon 6 plus n into n plus 1 upon 2 upon n into n plus 1 upon 2 equal to 100 upon 3. Now can I take n into, see what is difficult? Solving an equation. Can I take n into n plus 1 upon 2 common from numerator? Yes, I can. So that gives me 2n plus 1 upon 3 because 2 into 3 is 6 plus 1 because when we take this common we divide upon n into n plus 1 upon 2 equal to 100 upon 3. Can I cancel this? Yes, I can because this cannot be 0. N is natural number. So 2n plus 1 upon 3 plus 1 is 100 by 3. Multiply throughout by 3. So 2n plus 1 plus 3 is 100. So 2n is 96. So what is n? 48. So that's it for today.